Today is March 14th, 2020. My name's Ted Doskaris, and I have three Union Pacific locomotives here, G scale, 1/29th scale, that I'm going to see how they speed match so that I could couple them all together. Now, this first one here is a Aristo-Craft first generation SD45. The middle one here is a USA Trains SD40-2, and the end one here is an Aristo-Craft GP40. The one on the back here is a Southern Pacific SD40-2 USA Trains. So what I've done to these engines so far is this one here. The Aristo-Craft wheels were notorious for the plating coming off, and I use track power, so that's rather critical because if the wheel plating is coming off, the wheels can be pitted. And here's an example wheel, an Aristo-Craft wheel that that the plating was starting to come off. And probably can't see it too well here, but you can see like the brass underneath it. You know, with the shiny material coming off, and it looks kind of irregular. So I replaced those wheels with stainless steel wheels that I had made for me by Datum Precision. And the replacement wheels, these are the stainless steel wheels. They have reduced flange depth here that can be compared to the factory Aristo-Craft wheels. The flange depth is about 80 thousandths versus the Aristo wheels, which I believe were 120 thousandths to my recollection. So on some people's layouts they could have problems if the track work isn't good and they haven't debugged the turnout switches. So I've replaced those wheels on the on another issue is with the first generation of these SD45s from Aristo-Craft. The wheel spacing is way undergauged, and even on the later generations is undergauged, but not as bad. So I had two groups of wheels made, one for the first generation ones, such as this loco, and the way that is done is the Aristo-Craft uses tapered axles, and so the tapering amount can be varied by the machine shop that was done. So that the wheels are brought up to more NMRA standards of 1.575 back-to-back once they're installed. So that's what was done to this locomotive, and also added weight is put in there. Aristo-Craft had optional, in those days, leaded weights, and so that brought the weight up to the SD45 with the three total lead weights in the fuel tank area as the factory designed it and intended it to be. That brought it up to about 14 pounds. Now on the USA Trains SD40-2, I replaced the traction tired axles with the solid metal axle I should say wheels on the axles with the solid metal wheels rather than the traction tire wheels. And on this locomotive, or typical of USA Trains, the traction tired wheels were on the inboard axle facing the fuel tank, and they were replaced with the conventional axles that are in the center axle here, and they're all metal. And then the floppy axle, as it's called, doesn't have a how do you say, an axle tip that goes into the side frame. So another issue with these locomotives is they don't have electrical pickup at all at the pony axles, but only in the center and the inboard axle, and also they have skates under here, which can be seen, I think, here, and they rely on the skates mostly for the electrical pickup, and so there are wire connections that go into the side frame that pick up the axle tips for the inboard and center axles, and then the skates have a separate dedicated wiring to go inboard, or I should say inboard of the truck there, in the back of the truck there, electrical prongs and connectors. So they're tied together internally with the harness. And so that was what's going on with this SD40-2. Also, I added foundation plate weights. This is a little bit smaller than the ones actually in there. These are called foundation plates, and they have a hole in the center. And I use a toggle bolt. And when you take the fuel tank off, there's a hole, a like-kind hole in the plastic chassis. And in this case, I used 3 stacked 3-inch by 3-inch. I could have used 4. And put the toggle bolt through the center. And I also had, how do you say, a fender washer, so that the head of the toggle bolt wouldn't fall through. So I put a fender washer on top of there with a lock nut as well. And so I installed those weights. And another thing I did to better speed match this engine to the SD45, which is the slowest running of the 3 here. I put 1 ohm resistors in series with each motor inside, wired it that way. I actually put JST connectors on the end of each resistor prong where the wiring would go to the resistor prong, and mounted the 2 resistors, one dedicated for each truck, each motor for each truck inside the body shell there. So that was what was done with that one. And then this is the GP40, Aristo-Craft GP40. Again, the wheels I used, I changed to the stainless steel wheels. And they share the same motor block design, although this is a 2-axle design, and the SD45 is a 3-axle design. But they share, they call them, I forget what they call them, but they prime mover blocks or something like that. And so they have ball bearings, just like the SD45, so you can add a lot of weight to these and forego traction tires. And Aristo-Craft didn't use traction tires on the SD45 or the GP40 and most of their other locos. So I replaced the wheels on that, and I also added weight in the fuel tank area. And I actually took the old wheels and salvaged them and used them as weights. And I just ran a long, I think a number 6 or number 8 screw through them and with a nut, tie them together in different groups, and put them inside the fuel tank area. And so that brought the weight up to this GP40 to about 11.5 pounds. And I should have mentioned here the weight on the SD40-2 is with the 3 foundation plates of 3x3-inch types, brought the weight up to 11.5 pounds, very similar to the GP40. And again, the SD45 with the factory-led 3 factory-led weights is 14 pounds. So the idea here is I'm trying to, since I don't use DCC, I'm using track power with an Aristo-Craft train engineer. This is the older type, but on my layout I actually have a Revolution train engineer. And so I wanted to run these reasonably close together to see, and when you put a load of a train on it, it tends to equalize the loading on the locomotives. So that was my motive here. Now this test is with the SD40-2 with the resistors in series, 1 ohm resistors in series with each motor in the truck. And this is the Aristo-Craft GP40, and we'll see how they speed compare. Pretty close. It will vary a little bit depending on how fast I'm going to run these. So they're uncoupled. So they're pretty darn close. So when it's really low speed, they tend to get a little bit closer together. The GP40 runs a little bit faster at the real scroll speed. Now the SD40-2 is catching up to it in this reverse direction. Interesting. So, I'll couple them together. They're pretty darn close. There. And collectively, I would expect 4 amps. And that's what it is. High speed. Now I'm going to reverse it, slow it down, and reverse it. Now again, collectively I would expect about 4 amps at high speed. Slightly less than 4 amps. So there you have it. So they run quite well together. Now in this circular test track here, I have the 4 engines placed on the track. There's the SP engine. That's again, it's a USA Trains SD40-2, and it does not have resistors added to in series with the motors. And this one is the SD40-2 that does have the resistors added to the motors, and that was done by a recommendation of George Schreier on his website to avoid wheel pitting. He had problems with DCC. He uses DCC, but apparently uses track power, and so he discovered that these motors have a tremendous amount of inrush current. That is the USA Trains motors, electric motors, and it can cause pitting on the wheels. But of course, the other issue is I've done away with traction tires and to afford better electrical pickup. So this one has the resistors in there, and that served to actually slow it down a little bit to better speed match the Aristo-Craft SD40 or SD45, I should say. And on the last one here is the Aristo-Craft GP40. So I'm just going to run this a little bit and we'll see how they all compare when they're running. And we can see if I'm going counterclockwise, the SP engine is going faster than the UP engine, which the SD45 isn't even moving much at all, and the GP40 is going away from it. So just adding those resistors made the SD40 more compatible, I would say, with the SD45. So it does take some running back and forth if you just freshly put these locos on the track to sort of limber them up. And they can mismatch somewhat, but the least amount is better. Again, when it's on a train when it's loading on a train. So we can see it's preferential here for the resistors to be placed in series with the electric motors. And I'm kind of basing this test on the slowest loco here, which is the Aristo-Craft SD45. See, the GP40 is catching up to it. I'd say the GP40 is very similar to the SD40-2 with the resistors in series with the motors. And the SP one here is probably a little bit too fast to speed match. And being I don't have DCC where you could customize the characteristics of the operations of these locos, if you had DCC you could, I'm sure, with your control values, you could program it to match in that fashion. But being I just use a base station track power, I wanted to get them to speed match a little bit better. Now I took the Southern Pacific SD40-2 off the test track here that does not have the resistors that are added in series with the motors, and so now we have I put the GP40 on the front here, and the SD40-2 is in the middle, and the SD45 is on the end, and they're roughly approximately equally spaced here. And so I'll run them here, and so you can see the SD45 is still the slowest, and the GP40 and the SD40-2 are reasonably close. But I've had success running the GP40 with the SD45 without any problems. So I think this speed match is going to be good enough. Now before I took the GP40 off the track now, so we're just going to have the SD40-2 with the resistors in series with the motors, and the SD45. And before I couple them together, I want to run them and see how the current is, the current draw for these two. So we'll see that on the meter here. And it looks like right now at a low speed it's 2 amps. And it sort of settles down a little bit over 4 amps. Running at maximum speed. So it's about 2 amps per, a little over 2 amps per loco. Now in this test I coupled the locomotives together with the slightly faster one, the SD40-2 in the front here, it's on my left, and the Aristo-Craft slower loco, the SD45, on the back there. Now, speaking of couplers, I'm using Campac boxes here, and they're designed by me in concert with Colin Camarillo, and they accept direct center set KD couplers from the 907 kit, and also a plug is put in there to plug that big ugly opening that USA Trains uses to accommodate their hook and loops or their proprietary low mount knuckle couplers. So, and then in the case of the SD45, It has CNC machined aluminum metal coupler boxes that also accept the KD coupler from the 907 kit, the center set coupler. So we'll run these and see how the current compares. So we can see here that the coupler is in tension. They're coupled together. So that's not unexpected. So we'll see what the current draw is up here. So right now it's a little over 2 amps, and I'll increase the speed comparable to the way it was before they were coupled together. Down a little bit. So for a moment there it shot up to 6 amps. It seems to have settled to about 4.5, running fast. So I'll slow it down now and run it in the opposite direction. So it's drawing about a 1/2 amp more than it did when they were uncoupled. Right, so I'll reverse it. Couplers look like they're in somewhat in compression slightly, which is what one would expect. I get over here and where there's better lighting. So now the SD45 is going counterclockwise. The SD40 kind of pushing it. So here we're about 2 amps. And this meter is in series with the with my test track. Series with the power supply. This power supply here, and the receiver. So the receiver will shunt some current, but from my experience it's fairly mild. So it's about 4 amps, a little touch over. So that's with the SD40-2 seemingly pushing the SD45 to some minimal extent. So now I'll run the speed down. And we'll try it once more where the SD40-2 is pulling. So they're going slowly now. So this time it didn't shoot up to 6 amps. In fact, the current is settled to 4 amps. So they seem to have accommodated one another pretty well. So that ends the test for the SD40-2. Now for this test I put the GP40 ahead of the SD40-2, and of course the SD45 Aristo unit is on the end. And again, the GP40 is an Aristo-Craft loco as well. And the couplers appear to be in tension between the 40 and the GP40 and the SD40-2, and likewise the couplers are in tension between the SD40-2 and the SD45. So, and right now at the slow speed it's about 2 amps collectively for the 3 locos. So I would expect the greater current now. They seem to be 2 amps per loco when I run them fast. So I'm increasing the speed. So as expected, it's hovering around 6 amps total, maybe a touch less. Alright, now I'll slow it down and reverse it. Now with the engines in reverse and effectively pushing the SD45, and you can see the couplers in compression here between the, it's hard to tell. I think it's in compression between the GP40 and the SD40-2, and of course it is in compression with the SD40-2 and the SD45. So we'll run it faster. So running at a faster speed, it's just a little bit touch less than 6 amps from the way it looks. Interestingly enough, it seems to be a little bit less current than the other direction. So I'll slow it down and we'll run it in the opposite direction. And just confirm the current draw. Well, again, this test, actually the current in this direction is a little bit lower too. So that concludes the test.